The universe is running out of fuel. We have already passed peak star production, and the great stellar blackout has begun. You are living in the final afternoon of the Age of Light. Astronomers call it the Stellar Era, the 13.8 billion-year window in which the universe is capable of manufacturing new stars. We are now certain this era is finite, and according to multiple studies published in 2024 using data from the James Webb Space Telescope, it is ending faster than our models predicted. Stars require molecular hydrogen gas to form. This gas collapses under gravity, heats up, and ignites fusion. The problem is that the universe started with a fixed supply. Every star that has ever formed, every sun, every red giant, every supernova, has locked a portion of that gas away inside stellar cores, or blown it out of galaxies entirely through supernova winds and active galactic nuclei feedback. The gas is not being replenished. Once it is fused into iron and heavier elements inside massive stars, or ejected into the intergalactic void, it is effectively removed from the star formation reservoir forever. The numbers are stark. At cosmic noon, roughly 10 to 11 billion years ago, the universe was producing stars at a rate 10 to 20 times higher than today. We have been in steady decline ever since. Current observations suggest that the universe has already converted approximately 90% of its available molecular gas into stars, or dispersed it beyond reach. The Milky Way itself is forming stars today at roughly 3% of the rate it managed during its peak. JWST's deep field observations of early galaxies in 2024 revealed something unsettling. Even at redshifts beyond 5, when the universe was less than 1.5 billion years old, some galaxies were already gas-poor and ceasing star formation. They had exhausted their fuel reserves faster than simulations suggested possible. This implies the blackout is not a slow, distant event. It is an accelerating process that has already consumed the universe's brightest youth. The timeline is geological in scale, but inevitable. Within 100 billion years, star formation will have effectively ceased across the observable universe. The last generation of red dwarfs, dim, long-lived stars, will ignite with the final pockets of hydrogen, and then the production line will stop. The universe will not immediately go dark. The stars that already exist will continue to burn. Red dwarfs can last for trillions of years. But there will be no new lights turning on, no new solar systems, no new possibilities for life to arise around fresh stars. Eventually, even the red dwarfs will exhaust their fuel and become white dwarfs. The white dwarfs will cool into black dwarfs over quadrillions of years. Neutron stars will decay. Black holes will evaporate through Hawking radiation. The universe will enter the Degenerate Era, then the black hole era, and finally the dark era, a cosmos of infinite cold and silence, where the only matter left is iron and black dwarfs drifting in absolute darkness. We do not live in the dawn of the universe. We do not live in its noon. We live in the late afternoon, watching the long shadows lengthen, knowing that the night is coming. The stars you see tonight are among the final generation that will ever exist. So does knowing that we are in the twilight of the stellar age make you want to step outside and appreciate the stars more? Or does it make the universe feel more fragile and temporary to you? Drop your answer below and follow for the cosmic perspective they never teach you in school.